In the last video, I talked about finding the point where two lines cross by using a method called the substitution method. Because of their setup, some problems are more difficult to solve by substitution, however. An example would be 3x plus 2y is equal to 1 and 2x minus 3y is equal to 5. This is a more difficult problem to solve by the substitution method because neither of the equations are solved for x or for y. It would be possible to do some algebra and solve them for one of the variables, but we would end up with fractions in the problems, which would make it much more difficult to go through and solve. The other method is called the addition-subtraction method, or the elimination method. The names are synonymous. Some books call it the addition-subtraction method, while others call it the elimination method. So don't get confused if you hear both of those terms. The major idea behind this method is that we can add or subtract two equations together to get a third equation. An example of this idea would be having these two different equations. If I have x is equal to 2 and y is equal to 7, I could add the left-hand sides of the equations together and create x plus y, a third equation, add 2 plus 7 together and get 9 for the right-hand side of my third equation, and then I have a new equation that is true based on the first two equations. Certainly, if x is equal to 2 and y is equal to 7, I do get 9 for an answer. This is the idea behind the addition-subtraction or the elimination method. Here's an example of a problem using the addition-subtraction method. Let's say I have the two different equations, x plus y is equal to 6 and x minus y is equal to 4. I can go through and add these two different equations together. I'm going to add the two different equations together, so I have x plus x is equal to 2x, and then positive 1y plus a negative y eliminates the y's. So I have 2x is equal to 10. Notice that because I added, and because one of these is plus y and the other one is negative y, I was able to eliminate the y's. This is why some people call this the elimination method, because I'm working on eliminating one of the variables. So now I have 2x is equal to 10, which must mean that x is equal to 5. Once I know that x is equal to 5, I can go back into either one of the two equations and figure out what my y is equal to. If I know that x is equal to 5, I know that x plus y is equal to 6, so then 5 plus y is equal to 6, so obviously y is equal to 1. So that is using the addition-subtraction method or the elimination method. But I want to go through and I want to do exactly the same problem again, but this time I want to go through and I want to subtract instead of add, because it is called the addition or subtraction method. This time, if I subtract, now I am going to go through and I am going to eliminate the x's. X subtract x is nothing, just gives me no x's whatsoever. I have y subtract a negative y, which would be 2y. So 2y is equal to 6 subtract 4 is equal to 2. So I get y is equal to 1. Now notice I got y is equal to 1 over here, but I'm trying to go through and do this two different ways. So I would not go through at this particular point and just do it these two different ways. Once I know that y is equal to 1, I would substitute 1 in for one of the y's in the original equation. X plus 1 is equal to 6, so x is equal to 5. Once again, this is called the addition method, subtraction method, or the elimination method. And notice that this worked fairly easy for these two equations. Remember, in order to use this method, the idea is to be able to add or subtract the two equations together, and in doing so, be able to eliminate one of the variables in the third equation. Let's look at the following example. The first equation is x subtract 3y is equal to negative 1, and the second equation is 3x plus 2y is equal to 8. If I go through and if I add or subtract my x's, I'm not going to be able to eliminate them. The same thing with the y's. If I add or subtract the y's, I'm not going to be able to eliminate them. For that reason, I need to go through one more step. What I'm going to do is I'm going to go through and I'm going to rewrite both of these equations again. X subtract 3y is equal to negative 1, and 3x plus 2y is equal to 8. It sure would be nice if the coefficient in front of this x was a 3. That way, it would match the coefficient in front of that x as a 3. So that's what I'm going to do. I'm going to take this first equation and I'm going to multiply this first equation entirely by 3. If I do that, I now have that first equation being 3x subtract 9y is equal to negative 3. It's exactly the same equation because I did exactly the same thing to both sides. I'm going to leave the second equation the same. 3x add 2y is equal to 8. And now, since I have the same coefficients in front of the x's, I can go through and I can subtract these two different equations. 3x subtract 3x eliminates the x's. A negative 9y subtract 2y gives me a negative 11y. And negative 3 subtract 8 gives me a negative 11. If I go through now and just solve this for y, I get y is equal to 1. Now that I know that y is equal to 1, I can go through and I can substitute that 1 in for y in either one of the two equations. I'll choose to do it in the first equation, and I'll go back to my original equation. X subtract 3y is equal to negative 1. If I say that y is equal to 1, I have x subtract 3 times 1 is equal to negative 1, or x subtract 3 is equal to negative 1. Adding 3 to both sides then, I get x is equal to 2. So using the elimination method or the addition-subtraction method, I know that these two lines would cross at the point 2, negative 1. Sometimes you have to multiply both equations by something in order to be able to eliminate a variable. And here's an example. Let's say I have 3x plus 2y is equal to 29, and 8x subtract 5y is equal to 5. I could, if I really wanted to, go through and multiply that first equation by 2.5, which would make that 2y a 5y, but that would get messy with fractions. So instead, what I'm going to do is I'm going to go through and I'm going to choose to multiply both of these equations by something so that I can have the same coefficient in front of the variables. And I am going to try and get a 10 in front of both of those y's. If I do that, I could multiply this very first equation. I'm going to multiply it by 5. And I'm going to multiply the second equation by 2 to create my two new equations. If I multiply that top equation by 5, now I'm going to have 15x plus 10y is equal to 145. If I multiply the second equation by 2, I'm going to have 16x subtract 10y is equal to 10. So now I have these two different equations. 15x plus 10y is equal to 145, and 16x subtract 10y is equal to 10. Now I have the same coefficients in front of the y's. So I am going to go through and I am going to add these equations. The reason I'm going to add them is because one of the coefficients is actually a positive 10, while the other one is a negative 10. And since they are opposites, if I add them together, I will eliminate. So if I add these two equations together, I get 31x is equal to 155, which then I can go through and solve. If I divide both sides by 31, I get x is equal to 5. If x is equal to 5, I'm going to put 5 back into one of the two original equations. It doesn't matter which one. I'll put it back into the very first one. The very first equation is 3x plus 2y is equal to 29, so I substituted the 5 in for the x. So I get 15 plus 2y is equal to 29. If I subtract 15 from both sides, 2y is equal to 14, so y is equal to 7. So these two equations, if I were to graph them, would intersect at the point 5, 7. Here's a problem that I'd like you to practice with before watching me solve it. 3x plus 2y is equal to 4, and 5x plus 3y is equal to 5. Okay, hopefully you've had time to go through and do this particular problem. If I were going to do this problem, I can choose to eliminate either the x's or the y's. And I'm not sure which way you went through and did it, but I would probably go through and eliminate the x's. It, as I say, does not really matter. If I eliminate the x's, I want to get the same coefficient in front of the x's. So I'm going to choose to multiply the first equation by 5. I'm going to choose to multiply the second equation by 3. So now my two new equations, I have 15x plus 10y is equal to 20. And for my second equation, multiplying by 3, I have 15x plus 9y is equal to 15. Now I can eliminate the x's by subtracting, since they are both positive numbers. 15x subtract 15x eliminates those x's. I have 10y subtract 9y, which is just y. 20 subtract 15 gives me 5. So I know that y must be equal to 5. Now I'm going to go back into one of the first two equations. I'll choose the very first one, 3x plus 2y is equal to 4. And I'm going to substitute this 5 in for that particular y. So I have 3x plus 10 is equal to 4. Subtracting 10 from both sides, I get 3x is equal to negative 6. Dividing both sides by 3, I get x is equal to negative 2. So if I were to graph these two different lines, they would cross at the point negative 2, positive 5. Remember that for any set of equations, you can solve any of the three ways: by graphing, substitution, or addition-subtraction. Usually, the method you choose will depend upon how the equations are written. In the third and final video of this module, I will talk about some special cases having to do with systems of equations.